Let us start lecture 34. The course is phase diagrams in single component and binary systems, and today's topic we will discuss condensed ideal solution, and we will try to express or graphically present representation of del Gmix and then two partial mixing quantities. Okay. So, one is del G A bar M as well as delta G bar M for A as well as B. Okay. So, that particular thing will be discussed here. So, why we need to discuss this? So, let us first understand that. In fact, we will try to show these three quantities graphically, and then would realize that when we draw a tangent over the graph of delta G mix and that tangent cuts the axis on the pure A and B sides, and from the 0 point to the cut point, that particular quantity becomes delta G mix, delta G A bar M as well as delta G B bar M. Okay. So, and this will be used for deriving or deciding equilibrium between two phases when we consider a binary solution. Okay. So, that means when we have two component system and let us say we take alloy formation, solid solution or liquid solution alloy considering two metals A and B, and that time we have to judge the equilibrium between A and between two phases, this liquid and solid, let us say both coexist. Okay. How do we decide that equilibrium? For that we need to understand this graphical presentation of these two partial quantities. Okay. So, let us start. So, in fact, if we try to look at for the and rather ideal binary solution, fine, we have taken A and B, and we have taken the moles or atoms in such a fashion that X A mole fraction X A and X B equal to 1. So, that means we are making 1 mole of ideal solution, and we are fixing temperature and pressure fixed, and then we have seen representation or the graphically we have started seeing how delta G mix appears. So, it is basically 0 from pure A to pure B, any solution you take this will be 0. Del S mix we have shown, and then we have also shown minus T del S mix, and then that is nothing but delta G mix. Okay. And this delta G mix is expressed as X A delta G M A M delta G bar A M plus X B delta G bar B M. So, M is basically the mixing part, fine. And then we have also seen that delta G A M bar equal to plus X B okay, and delta G bar M B equal to delta G mix plus X A fine. We have also derived that. Now, we will try to see graphically over delta G mix versus X B plot. Okay. So, if we look at the plot, this is A, pure B, X B equal to 1, X A equal to 1, and X B varies this way, X A varies this way. Okay. Now, let us say I have taken a particular temperature and pressure. At that temperature, if I try to draw del G mix, since del H mix is equal to 0, so it will be simply minus T del S mix. So, the plot would be looking like this. Okay. Now, let us say I want to find out at this point what will be my these two partial quantities. So, let us say I have taken this composition, this is the composition I have taken, and let me just draw a tangent over that point, or at that point over that particular curve. So, if I draw the tangent, if I draw it with this color, fine, this is the tangent I have drawn, and it cuts the pure B axis, and this is the way we are actually trying to, this is delta G mix variation on this y axis, and x axis is nothing but mole fraction of A and B. So, let us say this point is, I am just marking those points. Let me just mark this point as A, B, let us say this point is C, this is D, or let us say E, and this point, let us say, let me put F. Now, what I can do, I will draw a parallel line with respect to the x axis, a parallel line is drawn, and let me put those points as F, G, H, and another parallel line, let me draw it at this location here. Okay. Let me mark it as G, H, I. Okay. This is I point. I can, this is nothing but delta G mix plot for a particular solution. Let us say we are taking a solid solution. Whether it is a solid solution, a liquid solution, it does not matter. Let us take solid solution. So, that means all the quantities, whether the mole fraction or those partial quantities or delta G mix is all for solid solution. Fine. Let me first try to calculate delta G bar M A. Let me just show it over this particular graph. Now, if I try to calculate delta G mix delta G x A, this particular quantity at F point. So, this is nothing but x A. Okay. So, this is the composition corresponding to F. So, that means if I try to find out slope at that point, so this will be the angle I have to consider. Okay. So, that angle if I try to draw, try to see geometric way, so then it would be I f divided by I d. Okay. Now, this angle, if you see these are this green line and this pink line both are parallel. So, I can write this particular angle, let us say if it is theta. So, this should be also theta, and then so this angle is also theta. So, now if I try to find out slope, if I take this triangle F H E, this triangle if I take, I can actually find out the same slope delta Gmix delta Xa at point F can be written as H E divided by Hf, because that would also give me the same slope. Now, once I find out that, what will be delta G mix at F is nothing but Cf. Is that correct? So, this is the part I am talking about. This is the part I am talking about. So, this is Cf. So, Cf is equal to, I can take AH, because it is a basically a parallel line between two parallel lines. This line would be H would be equal to Cf. Now, I will put this expression, and xp what? Xp is what? Xp would be, this is my xp, at point F. Okay. So, xp is equal to nothing but AC. Xp is equal to AC. Now, then delta G bar M A would be equal to delta G mix plus XB okay. I can write that. So, then this is nothing but AH plus XP equal to AC into HE divided by HF, and this AC is also equal to HF. So, then I can write AH plus HF, instead of AC I replace with HF, into HE plus HF. So, this HF are cancelled. So, then delta GAM equal to AH plus HE, which is nothing but AE. So, I could see that this is the quantity, this length is nothing but delta G A bar M. Fine. So, now you could see that when we draw a tangent at any point over delta G mix, that crossing point of that tangent with the pure A side and that particular length starting from 0. So, this is basically 0, because delta G mix at x a equal to 1 is nothing but 0. So, there from there, if we draw that, it becomes delta G A bar M. Now, we have to also find out delta G B bar M. Okay. So, in order to find that, similar geometric process will just take up. If you see now, for the, I have to do it here itself. For that, let us see what are the things we can find out. So, this is one part. Now, the next part, let me do it here. So, if we try to find out delta G B bar M equal to delta G mix plus X B X A X B. So, then I can find out delta G mix delta X B. Okay. So, in order to find that, I see that this is nothing but since now I have to start from with respect to B. So, then it comes out to be H E divided by H F. Now, we have seen that this is same as I F by I D. So, is equal to I F divided by I D. Okay. Now, I know that X A, this is one part. The second part is here X A at point F. At point F is equal to, we have already seen that this is C F, C B actually, X A, this is basically B C, fine. X A should be B C, because I have to start from X A equal to 0 to increase to increasing X A. Okay. So, now that is B C. So, now I could see that delta G B bar M should be equal to delta Gmix plus X A d delta Gmix dxb. So, I can put it, this is nothing but Cf plus xb equal to Bc into, this is nothing but If divided by Id. Now, Id is nothing but minus of Cd, okay, because Id is, we are taking this way and Cd is basically B minus of Bc. Okay. So, when we try to take Xa, say we have to take Xa equal to 0 to whatever value we are getting at point F. So, that means it should be minus. So, then I can write equal to Cf minus Id into If divided by Id. So, these should get cancelled. So, then it becomes Cf minus If. So, If, if I try to look at here, If is nothing but, so If is nothing but from here I can see that If, so that means from here we get delta G bar M B equal to Cf minus, I have If can be taken as dg. So, dg I can write that, since If equal to dg. So, then Cf can be replaced with Bg. So, then Cf is replaced at Bg. So, it becomes Bd. Okay. So, that means from here we can see that delta G bar MB is nothing but Bd. So, this quantity. This quantity. So, that means again here also the tangent crossing the line y axis when x b equal to 1, that value corresponds to the partial quantity, which is delta G bar B m. Okay. So, now we could see that any point over this particular delta G mix, graphically we can also find out what is the quantity that represents those two partial quantities. So, now if I try to look at some other cases, let us say if I try to see two different points, let us say this is my delta G mix So, here if I try to see, so then this is nothing but x b this way, this is pure A and pure B, x A equal to 1, x B equal to 1. Now, this quantity is nothing but delta G bar M B, and this quantity is nothing but delta G bar M A. Now, instead of that, let me just take another point here. So, I have to draw a tangent here. Then that case the value would be, so this is the composition I am taking. So, initial composition, the previous composition was this. So, now here the value would be, this is the quantity for delta G at let us say these are the 2 points, let us say this is C1, this is C2, composition C2, and this is composition C1 with respect to B, x B. So, this one is at C2 and this one at C1 and this one at C1, and then the other quantity is here. At C2. Okay. So, like that way we can find out just by drawing the tangent what would be the values of those partial quantities. Okay. So, this is very important, remember. So, in the next class we will try to understand why this becomes important, because the next class we will try to understand the equilibrium between two phases. And remember, here C1 and C2 both are for the same phase. Okay. So, this is, if we take this is a solid solution. So, every quantity, partial quantity are basically, even the compositions are in solid state, but at two different compositions, fine. So, now next class would be very important class, because we will be showing, now we will be going into the solution phase. Now, this is basically the mixing quantity, del G mix. Now, we will try to see how graphically we can plot the free energy for the solution, because finally we are actually having the solution. So, that would be interesting. So, till then let me stop here. Thank you very much.